So during our last class, we talked about Mendel's experiments and his experiments on pea plants. Today we're going to be taking a look at what Punnett squares are. And Punnett squares are diagrams that help to determine the possible genotypes and phenotypes of the offspring. So if we know what the parents are and their genotypes and phenotypes, we could see, using this Punnett square, what their offspring may turn out to be. Okay, taking a look at Mendel's experiment. Okay, in his first experiment, we saw that he had two flowers, and they were both purple. Okay, and these were the parents, the parental generation. And when he crossed them together, he found out that the F1 generation, or the first generation of offspring, turned out to be just like their parents, all purple. And he did this for white also. If both parents are white flowers, all their kids will have white flowers. If both parents have tall stems, all their offspring will have tall stems. So we're going to use the Punnett square to figure out how that actually happens. So the first thing that we have to do with a Punnett square is to determine the alleles. And remember, alleles are the genotype, the letters that we use to determine a trait or a phenotype. Okay, so here's what we have. We have in his first experiment, we saw purple flowers were dominant to white flowers. So I have here the table. The phenotype or physical trait is purple, and it's dominant. So the allele or letter we're going to represent purple would be a capital P. Okay, we represent with it a capital P because it is the dominant trait, and dominant traits get the capital letters. Since white is recessive, we're going to have it be represented with the allele that is lowercase. And now some letters, they look the same if they're capitalized or lowercase, so I always tell all my students, okay, to determine the difference between them, because I need to see, you know, your capital versus your lowercase. You can also go ahead and either put a line underneath the lowercase letter or make it into a cursive. Now that you've gone ahead and determined the alleles, now you have to figure out the parents' genotypes. Now in this situation, okay, both parents were purple. So in this case, it says both parents are homozygous dominant for purple. So we got to write that down. So parent 1, okay, what is the genotype for parent 1? Remember, you have to have two letters. So since it's homozygous dominant, homozygous means same, and they're both dominant, I'm going to have two capital P's, okay? Now, parent 2 is also homozygous dominant. So homozygous means same, and dominant means capital letters, okay? What's the next step, okay? Number 3 says draw the Punnett square. So we're going to be focusing on Punnett squares that have only 4 boxes. We'll be taking a look at more complicated Punnett squares in later lessons. Okay. Step number 4, write the parent's genotype either on the top or to the left of the Punnett square. So it doesn't matter if parent 1 is up on top or to the left. It really does not matter. So in this case, since we said parent 1 was homozygous dominant, I'm going to represent it by 2 capital P's, okay? We said parent 2 was also homozygous dominant, so that second parent I'm just going to put onto the side. 2 capital P's, okay? The next thing that we're going to be doing is we're going to, step 5, okay, we're going to fill the genotypes and the phenotypes of the offspring. So, how do we fill in this Punnett square? Well, remember I told you that each parent will give a allele. Okay, so if this is parent 1, it's going to give the allele capital P. Parent number 2 will give its allele, okay, also capital P. Okay, same thing here. Parent 1 gives a capital P, okay, and then parent 2 gives a capital P. So you're basically writing the letters that each parent's going to give. It's either going to be represented from the top or the parent's going to give it from the left side. Okay, and you should start to see that each parent for all of the offspring that are available, will have a capital P. Now that we know that, so that parents are on the outside and the offspring, their probability is on the inside. Okay, so let's figure out the offspring's genotypes. What are the possible genotypes that we see? Well, I only see one type of genotype represented, and it is homozygous dominant, or it is 2 capital P's. How often do I see that? Well, I see it in every box 4 out of 4 times, or if I were to go ahead and write it into a percentage, it's going to be 100%. So no matter if they have, these two parents have 100 offspring or 50 offspring or 25 offspring, 100% of the time their offspring will be homozygous dominant. Let's take a look at the phenotypes. Okay. What are the possible phenotypes that are represented in the offspring? Well, each box is represented with homozygous dominant, or 2 capital P's. And I know that if it has a capital P, it is represented with the phenotype of purple. So, purple flowers. How often do I see purple flowers? I see it here, 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 and here, because each one of them all has at least one capital letter or allele. So it'll happen 4 out of 4 times, or if I were to take a look at a percentage, 100% of the time. That is why, okay, when we saw his experiment, his first experiment, 2 parents that are purple, 100% of the time their kids will be purple. And 100% of the time their genotype of the kids will be homozygous dominant.